Hello. Hopefully y'all can hear me. Welcome to the fourth edition of TGIK. If you could give me a shout out in the comments and let me know that you can hear me. Every time I do this, I'm a little bit unsure of how all the audio and everything is going to work. And I'm also going to tweet out something real quick. If y'all can stay with me, I just want to make sure that everybody can join. Let me find something that I can respond to here. There we go. Quote tweet. Starting now. Come tune in. All right. Well, so welcome. Okay, yes, y'all can hear me. Great. Like I said, every time I do this, I'm a little unsure of how it's all going to work. So today we're going to cover some of the patterns of how we do authentication, authorization, and the sort of probably most capable, most common authorization method that we have right now for Kubernetes, which is RBAC. So hopefully that's going to be something that's interesting to a lot of folks. We'll see how much we get through here. There's going to be some stuff that I'm doing here that I haven't done before. I've sort of read the docs and looked at it, but I've never actually sat hands on keyboard and done some stuff. I have used RBAC, but like this whole flow of actually being able to demo it. So you're going to probably see me screw some stuff up, and that's okay. I mean, that's how we all learn, is to watch how this stuff works. So with that in mind, let me go ahead and start sharing my screen here. I went through and created a cluster using the Kubernetes AWS Quick Start. And this is actually a pretty bare bones cluster that we start here. And what you do as you run this is there's this command that you can copy and paste that actually copies out a kubeconfig file from the master server, and then you cache that locally. And so here we are. Let me look at this. So I've done that. So what I've done is I've set my SSH key, and then I've copied this down. Here, I'll run it again so that you can see how it works. And let's hopefully you can read it. Let me make the typeface bigger here, and my face is in the way because I got a big fat face. Let's see. Let me do that a little bit. Okay. So there you can see it. So just really clear, so what this is doing is it's saying I want to SSH in to this bastion this is the IP address of the final target that we're trying to get here, but we're going through a bastion host. And so this proxy command says SSH in first to the bastion host, run netcat, which is sort of a network forwarder type of thing, and then through that channel connect to the SSH of the final target, which is my master that the CloudFormation template brought up. And then I'm going to download a file from that, and I'm going to cache that locally. So we'll go ahead and run that, and it goes ahead and does that. And it says killed by signal 1. I'm not sure exactly what that is. I assume maybe that's like the inner SSH getting killed in a way it doesn't like. I'm really not sure what's going on there. It says cannot see the screen. Shoot, what's going on? Why can't you see the screen? Transition. Oh, I have it in studio mode for OBS. I am sorry about that. That is confusing. Can you see the screen now? Like I said, every time I do this, I'm not sure what the hell's going on. Yeah. So okay. So hopefully you can see it now. Let me go through, and I'll go through this again. So this is the inner command here that SSHs into the bastion host, which is this thing here, and runs netcat. The %H and %P are actually replaced with the host and port that we eventually want to actually have this thing targeted to. And so this is this proxy command thing. Now here we're doing it all on one command line, but like this is the type of stuff that you can set up in your SSH config when you have these things over a long period of time. So it's kind of SSH voodoo going on here. And then this is the eventual thing. We're copying down kubeconfig. That actually ends up being here. And let's take a look at what that looks like. I'm going to flash this on the screen here. And I'm going to make the font even a little bit bigger. And it's probably, for me to actually show this on the screen is a bad idea because I'm going to be showing you secret material. But I'm betting that none of you can like screen scrape and grab the key during this program and log in. So I know that this is a temptation for somebody to like pause the stream and actually sort of grab the key and kind of screw things up, but please don't do that. So let me go ahead and do it because I do want to show what this looks like. So actually, let's open VS Code here. There we go, and we're going to look at this thing here. And this is the information that you need to connect to a cluster, and this is pretty much the sort of the minimal set of information. So yeah, so somebody could actually take a screen capture and OCR this, and they could actually get to my cluster right now. So the thing that we're actually doing here is the first thing to recognize here is here's how I actually contact the cluster. So this is the cluster ID stuff. And what we have is we have the root certificate that I'm going to trust because we're doing an SSL connection to the TLS connection to the server. And we're not using public certs. Like we could go and perhaps get a certificate from Let's Encrypt and then use, I'm not wearing the t-shirt today, but we could do that and then use that. That's more complicated. And okay, so Justin is saying that there is some other SSH voodoo that doesn't actually require netcat, but I haven't seen that. That's probably a newer SSH feature, or maybe I just haven't seen it. So that's cool. Okay, so this is the SSH -W is the one that we're talking about there. So I'll have to check that out. So yeah, so Kubernetes lets you specify explicitly which root certificate you want to trust. And as we start moving towards security in a sort of data center world, and as you look at corporate environments, the set of root certificates in the public key infrastructure world that's appropriate for the browser may not be appropriate for a more tightly controlled situation like when you're running in a data center. And so a lot of times whenever things are connecting over TLS in things like Kubernetes, but this is common across a bunch of other things, we make provisions for people running their own private certificate authorities and only trusting those certificate authorities and not trusting the browser-based certificate authorities. And so that's what's going on here. So as part of the bootstrap process, we create a new certificate authority, and the Kubernetes API server actually plays that role as CA, and this is the certificate for that. And then here's the address that we're actually connecting to. This is an ELB. So that's enough to actually start hitting my server, but you can't authenticate to the server. That's what you need this stuff for here. And by default, we have an admin user that we create for as part of the kubeadmin quick start setup. And that thing actually has its own certificate and key. And so this is essentially our password for connecting to the server. And we actually establish mutual TLS authentication. Yeah, so Mario here is saying that it's SSH 7+ when they actually did this stuff. Yeah, I don't even know, like, what does my Mac come with? Maybe -V? Oh, it doesn't. Okay, yeah, so the Mac actually comes with a newer OpenSSH. So yeah, I probably do have that feature. So that's very cool. Okay, so where was I? Okay, so yeah. So now I can use that, and if I do export, what I'm saying here is I'm going to use the kubeconfig in whichever directory I happen to be in. And that's probably a little bit dangerous. Anytime when you put like a dot in your path, you got to be a little bit careful. But this is pretty good here. And then I can do kube control get nodes, and you can see I'm connecting to the cluster. So what's happening here is I'm creating I'm going through an ELB and that's in TCP mode. That's how the quick start is set up into the master, and I'm establishing a TLS connection. And I know the root certificate to trust, and and that root certificate is also signed, also has a subject alternate name saying, hey, I'm able to be this ELB. So we actually allocate the ELB before we actually create the cluster, so that we actually know the name of the ELB while we're creating the cluster. And then I present my client certificate that says, hey, I'm the admin user in this thing. Now, I don't know, is there a... So I'm going to do a search here, Kubernetes, who am I endpoint. A lot of times when you do this stuff, you want to actually have a way to actually ask, hey, who am I authenticated as? And I don't know if Kubernetes provides one of those. No, that wouldn't be it. Kubernetes auth data endpoint. Let's see. So we'll look at the documentation. This is the type of thing where I start doing this and I start wondering and then I have to look it up. We'll see what happens there. But anyway, so I'm coming in as the admin user here. Let's see if somebody, like kube control, I think there might be a way to actually help. There is options. Okay, so we have a lot of options here. One of those is you can override. So it turns out that that kubeconfig file is actually a little bit of a database, and so you can put multiple users in clusters and have context that refer to things. And so there's stuff that you're seeing here that actually overrides some of that. I think we have, if we do kube control get nodes dash v, let's say 5. Did I have to? I probably have to do that maybe 10. There we go. So let's see. So this actually dumps a whole bunch of stuff, the requests and the responses and stuff like that. So there's a whole bunch of debugging info, but the response header here, I was hoping that it would show up in the response header, who I'm actually authenticated as. Oh, here's the curl command that I can do if I wanted to actually go ahead and do that. So this is fascinating. Oh, but this won't do, this is giving me a 403 forbidden because the curl command that it generates in there doesn't actually do the neutral TLS. So this thing is not loading for some reason, kubernetes.io. Okay, well, let's keep moving because I think that's interesting. Okay, yeah, so here you can see it says user system.anonymous. So when you get an error, it tells you who you are. Okay, so the way that it works is that the API server for any incoming connection, it goes, so I'm sorry, looking at the comments here. Can't post a link, but Chuck is saying that there's an issue on this. Chuck, you're way ahead of me. And then somebody's saying we can do kube control config view. This is great because this shows you all the information that you have, and it shows you the name of the user, but this is actually just local to your kube config. There's no guarantee that this user actually matches up with the identity that the server is going to assign it. So this is just, so this admin name here in the kube config is just so that I can actually reference it in the context here. So there's kind of some confusing levels of indirection that's going on here as we do this stuff. Okay, create a who am I service. Yeah, so I'm not the last one to think about this. About a year ago, somebody's like, and then there's like, it's one of these things where there's a ton of discussion. And 2 days ago, this was great. And PR to add an authentication info response. So this is what I saw. So I knew this was happening. This stuff is in progress. Oh, this was closed. Why did it get closed? Oh, it got sat fallow and didn't happen. And so impersonate. Okay, so but there's a lot of stuff in here so that you can actually do a request and then get information about the server actually telling you how you were actually authenticated so that you actually get some feedback around that stuff. All right, so what happens here is when a connection comes into the API server, there's a whole bunch of ways that Kubernetes can assign a user ID to that connection. And it depends on how you're authenticating to it. And you can have multiple authentication mechanisms in play at the same time. And the idea there being that you could have one type of authentication system that is more sort of a raw, like this mutual TLS auth. You can have another thing where maybe you're integrating with some sort of single sign-on type of thing, and you're using that system, get a token, you're passing that token to Kubernetes. Kubernetes is taking that token and then verifying it. There's other mechanisms where, and these are a little bit vestigial at this point because we're actually looking to move away from it, where your authentication mechanism ends up being a flat file with just plain old token pairs. And so we'll go ahead and play around with that a little bit. And so the idea of like who you are in a Kubernetes cluster is incredibly flexible. And I think that flexibility is a real feature because it lets you integrate in a bunch of different ways. But it's also a problem because it means that when you talk about how do I authenticate to my cluster, there's no one right way to do this. And this is something that, I personally would like to make it easier for people to actually take advantage of this stuff. So let's go through, and what we're going to do here is we're going to SSH into the master. And we're going to do a little bit of surgery here because we don't have any other users on this cluster. And so there's two ways out of the box that it's really easy. And if I can pull up the documentation for Kubernetes seems to be having a hard, there we go. That's kubelet authentication. So let's go through and we'll look at all the different ways that you can authenticate. So X509 client cert. So this is essentially what we had before. We have the static token file. So this is the thing that I was talking about. We're going to play around with this a little bit, and then you can put this bearer token in a request. There's a static password file where this uses basic auth, which is, HTTP auth that is so insecure it's not funny type of thing, because it essentially takes the password and puts it on the wire directly versus doing some sort of hashing challenge type of thing. There's service account tokens, which are a built-in token mechanism. There's OpenID Connect, which is a way to sort of integrate with, say, Google or something like that, or any sort of OIDC. The CoreOS folks actually went ahead and did a lot of work behind this to get this integrated. And then they have this sort of OpenID Connect sort of meta server called DEX that's really interesting for doing this. There's webhook token authentication. This is the idea where you can have, anytime you actually make a call, you pass a token, and Kubernetes is like, I don't know what to do with this token. So it then asks a webhook, and then that webhook then turns around and actually does the authentication, says, oh, I know this token. This is Joe, and I'm going to go ahead, and he's part of these groups, and it returns that as part of it. And so this is incredibly flexible. You can essentially do anything you want behind this with this token authentication, but then it's up to you in terms of how you allocate those tokens, how you verify them, that type of thing. There is an authentication proxy. So let's say that you actually have an authenticating proxy in front of your API server. What you can do, and that's the only thing that will ever talk to your API server, what you can go ahead and do is actually say, well, if a request comes in and it has these headers on it, then I'm going to actually trust those headers, and I'm going to authenticate with that. And so, so you can have you can essentially put a proxy in front of it that essentially does this stuff. And then if you're, I believe there's some, I haven't played with this, there's some experimental support for integrating with Keystone. And Keystone is the authentication framework for OpenStack. And so there's an ability to integrate with that. So let's see, so we can play around. We have to actually create some identities here. We can either do the static token file, or we can do the X509 client certs. Which one do you all think is more interesting? Can you vote? Give me some comments here. Yeah, anything? I got to wait for the delay here to see if folks want to do it. I think it's probably a little bit easier to do the token file, but you're actually editing files on the server, so that's a little bit trickier. Okay, so JJ's saying the X509 one. Anybody else have opinions? X509. All right, we'll go ahead and do that. Now, Okay, service account base. Okay, so service accounts, I do want to mention that. So service accounts are great, but service accounts are really the most useful when you're talking from on cluster to cluster. So like if you're running something inside of Kubernetes and you want the thing running inside of Kubernetes to be able to actually talk to Kubernetes, that's where service accounts really come in. The stuff that we're looking at is how do we actually access this from outside of Kubernetes. So we'll do the client certs. Okay, so let's see. So this is a joke. I don't know who wrote this, but they actually used my name in the examples. I'm kind of flattered and kind of scared. But there's an appendix, and I know that I saw this PR go in a little while ago on how to actually go ahead and generate certificates. Okay, yes, using the certificate API. So here's the thing. So if you own your own CA, it's up to you using that CA for how you want to mint certificates. And you can do anything you want there to be able to do that stuff. And so there's like CFSSL, which is this Cloudflare SSL framework written in Go. You can use that as a CA. Vault. HashiCorp Vault actually can act as a CA. You can use OpenSSL to be able to do this stuff. But once you actually have and then it's up to you in terms of how you want to sign those things. But for ease of being able to do stuff with Kubernetes, for example, like what I'm doing right now, Kubernetes has a built-in certificate authority that is used by default to do automatic bootstrapping and certificate rotation for things that are used inside the Kubernetes control plane, but it also can be used to give certificates for users. So the first thing we're going to do here is let's go ahead and do this. And I saw this. So trusting TLS in this. So we should have this all up and running already. Let's see. Have I done this? I don't want to do this. Do I want to do this now? No, I don't want to do that. So let's do brew. Okay, we're going to actually go out. Okay, we're going to brew install CFSSL. Let's see. Is that going to work? Is magic stuff going to happen? Updating Homebrew. Homebrew won't do anything unless it updates itself. There's actually a command to update Homebrew, but like, why would you every time you do anything? And you can see all this stuff. Okay, so this is actually installing that. And so we're going to use CFSSL to actually create our certificate. And we're going to create... instead of doing this on the command line, I'm going to do this here. And we're going to go through and we're going to call this thing. Wait, what is going on here? My service, my... No, I don't want that. Host. All right, so this is a little manual, but this will be fun. This will be fun. Requesting a certificate. So this is, I thought when I saw this before, you could use it for users. Let's just give it a try. So we're going to do this, and so we're not going to do hosts. So this is let's see, CFSSL gen key, because what we want is the common name to be just like I should have done this before because I'm making this up as I go along here, but hopefully we'll get some interesting learnings out of this. Okay, so here's an example. Hosts, keys. What is this JSON schema though? Names. Okay, we want the names. This is what we want. And we will do O equals, I believe we use the organization, users, or let's say cool people, and we're going to go through and no, we want the CN to be Okay, Jacob says, oh, you wrote a post about, let's look at your post. Okay, Jacob X509 cert thing. Because I know that this is, oh, look at that. Jacob, all right, awesome, man. Wait, this is from March 2013, so you are prolific here. And we'll go ahead and look at this. No, that was, here's a tectonic. That's, let's see. See if we can find it. Okay, adding users. Yes, thank you. I remember seeing this, but there was also some other ways to do it. Okay, so you're using OpenSSL to do this. So let's just go ahead and do that. We'll do that. My name is Joe, not Jacob, so I'm going to do that. And this goes ahead. So now we created a certificate. And then we're going to request, okay, we're going to do the subject here. So now this is the weird thing. Like X509 is just crazy because what it is, and I saw that there was an example here. So what it is the name here ends up being a, so we'll just go ahead and do something like that. The name here ends up being a ordered list of unordered key value pairs. So this is and this is the same thing with LDAP. And so nobody understands how this stuff works, but cool people. Okay. So we'll go ahead. Well, now it says Jacob. Now that's still not right. So key, my name is Joe, out, Joe, CN, Joe. Now we're going to do users Joe here because what you'll see is as we start looking at roles, it's really common to actually have a little bit of a namespace there going on. Okay, so now that is my CSR, which stands for Certificate Signing Request. So quick primer on how this stuff works. The whole idea with public-private key, cryptography is that you create two keys, one's public, one's private. As much as possible, you want that private key to never go anywhere and actually stay in one place. But you want to actually establish trust. So what you do is you say, hey, I want somebody to identify me this way, and I'm going to sign with that with my public key. And then that's a certificate, and then it becomes a certificate signing request. You hand that off to the server. The server says, yes, I know this is you. Via some out-of-band mechanism, they're able to trust that. They then go ahead and stamp that thing and say, yes, that is you. And then you get a signed certificate. And so then if you present that signed certificate and to somebody and then have your private key, you can prove that you are who you say you are. Okay, so let's continue going through Jacob's thing here. And then we want to go ahead and sign that. And so this is how we actually do a certificate signing request here. And so, okay, so we're actually looking for groups authenticated is the groups that we're looking for here. And this is the name of the request. So this is all a little CSR YAML. And the request here, we have to go ahead and get that. And if we look at the CSR, let's go ahead and let's see. I wonder if I can do that, if it's actually going to be happy with that. Let's hope that it doesn't mind that I think that's how the blocks work. Usage is digital, and so now we're going to create that. Oh, it didn't like that. Okay, so line 9, what did I do wrong? Okay, so what is the block string YAML? Okay, and Jacob's also asking, how do we revoke this stuff? I don't think that there's a way to revoke it right now. Okay, so we want to do this. Does that work? Do we have to base 64? Did I not read your tutorial here, Jacob? Do we have to base 64 encode it after? Because it's already base 64 encoded. All right, well, give it a try. Oh, here, look at that. You're actually saying it. I'm just not reading stuff. Okay. Okay, cat. That gives us, and then you can do that to PB copy. And then we can go here and we can damn the torpedoes and stick that in there. And that's all in one line. And then I can go through and I can do the create. Okay, so now that user request is created and we can go through and we can actually go ahead and approve it. So now what I'm doing is I'm using my sort of root certificate that I was able to authenticate to actually approve this other certificate. So now there we go. We're up and running. That thing is approved. Let's see. And now I can actually go ahead and get it. So now as part of this, the CSR user request, Joe, we should probably wrap this up in a program or a script. So you can actually see what it looks like here. So here is the request. This is my CSR, and then this is the final certificate. So this is the thing that I actually want to have here, right? And so what we can do is we can do this command line here, goes through, and the JSON path there says I actually want to like just take that one value out of the result, and then I want to base64 decode it. Oh, what is this thing? Maybe there, no. What did I do? Invalid option D. Oh, you know what? This is probably because I'm on a Mac. Okay, there's my certificate. So that looks right. And all right, so now I actually have my certificate and my private key here. And what I can do is I want to put those into a config file. So what Jacob does here is he actually goes through and he actually creates a new config file to be able to do this stuff. And like looking to embed certs and actually set the, we're not going to do that. So what we're going to do is I'm going to copy the cube config. I'm going to call this Joe-cube config. And then I'm going to go to the editor here. I have Joe.cube config, and I'm just going to actually swap out some stuff here. So I have my client certificate data. Now my guess is that I have to base64 encode that. So I'm going to do Joe.crt base64 and then PB copy. So that's my client certificate. And I have to like that. Okay. And then, wait, what did I do wrong? So user, name Joe, user. Okay. So there we go. That's, okay. There. Okay. And then the next thing I want to do is I want to get the key data. So joe.hem base64 and then put that in there. Okay. So now, it says I lost the key. Did I lose the key? How did I lose the key? Client certificate data. No, okay, I got it now. Okay. I think you're a little bit behind. The delay confused me there. Okay. So we should be up and ready to run now. Oh, and then since this thing is now called Joe, I'm going to do that. I'm going to do Joe here, context, and then the name. This is the name of the context. Doesn't matter. Current context. So this is so this config file is super flexible, and there's references within it with names. At this point, after using this stuff for a while, I think the easiest thing for most users is to have a single config file per cluster name combination that they're working with. And I'm going to be looking to maybe do some sort of tools and flows that really help people manage a lot of kube configs, because I think that is something that folks deal with a little bit. So Kubernetes, so now we do K. So we can do export kube config equals, let's see, Joe-cube config kubeconfig get nodes. And, oh no, kube control get nodes. Okay, so this is good because what we actually had here is we actually say we authenticated as users.joe. It didn't say I didn't recognize your authentication, because if we actually go up and like, let's just like remove something out of my client key data here and actually go ahead and do this, it's going to be like, I couldn't load it, something was wrong, so that didn't happen. So there's a whole bunch of stuff. Okay, so Paul says that he has his own thing for actually doing it, for creating certs. Yeah, but we're already past that, Paul. We're past you. You could have helped 20 minutes ago, but I think we're past that right now. But okay, so what happened here is we've authenticated as Joe, but now it's telling us that Joe's not allowed to actually look at the what's going on in the cluster. So we've gotten to this hurdle where we've authenticated as a new user, but we are failing authorization. And so we've made progress. We're 37 minutes in, and I haven't talked much about RBAC yet, and I apologize, but this is part of the story, and so we've made progress. Now, this is authentication. Now, authorization is another thing where there's all sorts of different options in terms of how you authenticate. Okay, so Paul says that his script, and Paul, I don't know if there's a way for us to actually grab this stuff and put it into the, I want to try and get the live chat into the stream after we post it. But there's a good reference there to a Docker container that he has for doing that stuff. Okay, so that's authentication. Now, authorization is a whole nother ball of wax. And so generally what happens is it is pluggable also. And there's a bunch of different stuff that we can do around authorization. And so authentication is who it is. Authorization is what can they do. And there's a plugin model, and by plugin in Kubernetes, what we mean is that there's an interface and there's a bunch of built-in methods and built-in sort of implementations of that. And with command line flags, you can switch which ones you use. Something is going on with either my network or the Kubernetes website right now. So raw authorization. Now, there aren't quite as many options for authorization as there are for authentication. There's this ABAC mode, attribute-based access control. That has mostly been deprecated at this point. You can do a webhook where it's like if you have your own idea of how you want to do this stuff, and basically there's a call out to the webhook saying this user with these groups wants to access this resource, and you can do whatever you want at the other end of that webhook. In 1.7, there's a specialized authorizer for nodes so that we can really scope down in a way that's hard to do with RBAC, which nodes can do which things. And then RBAC is the new hotness, and this is role-based access control. This is a backport from OpenShift that the Red Hat folks spearheaded, and it was it's been more widely deployed starting with 1.6, going on with 1.7. It's still relatively new on the scene, so you'll see a lot of recipes, a lot of Helm charts are not quite ready to actually work with RBAC. But we're going to go ahead and play with it right now. Now, there's 4 different modes. There's 4 different things that you have to think about in RBAC. There's roles, cluster roles, and role bindings and cluster role bindings. And the way that these things work together is kind of makes sense when you really understand how namespaces work in Kubernetes. When we create objects in Kubernetes, like whether it be pods or nodes or whatever, there's a decision. Are these objects created under a namespace? So pods are. Every pod lives within a namespace, right? And so we can see this if I do kube control get pods. I don't see anything. Oh, I can't do because I'm Joe. So let's go through and we'll fix that at some point. But we're going to switch back to using the admin kube config. So I can do get pods, and it says no resources found, right? It turns out I'm in the default namespace. So I can actually do n default. Same thing. That's a no op. But if I actually do n equals kube system, you'll see that we are running a lot of pods. And so namespaces are a way to carve things up. But there are some resources here that don't run in namespaces because they're a cluster-wide type of thing. And if we actually looked at, let's see, at the CSRs, or actually, if we do described, we'll see a bunch of stuff. So we had the certificate signing request. Okay, so So I can do get CSR. Here you can actually see, here's the user request Joe. If I do, this is my, when I actually look at that thing and get it, what you'll see up here in the metadata, this thing has a name, but it doesn't have a namespace. And so the CSR is an object in Kubernetes that doesn't have a namespace. And there's others like that. And one of them, the biggest one is probably nodes. Cube control get nodes, these things. So like if I go through and get one of these nodes, extra key there. What you can see again is there's a bunch of metadata here. Here's a name, there's no namespace here. So these things are called cluster-wide resources. All right, so roles are namespaced resources and cluster roles are cluster-wide resources. And so whenever you create a role, you have to talk about a role within a namespace. And whenever you actually talk about a cluster role, that's something that actually talks about, it's a policy that you can write that cuts across the entire cluster. So let's go ahead and look at these things. Cube control get roles. And these are the predefined, and there's none. But I can do all namespaces. And you can see, okay, there's some in Cube public and Cube system, there's a couple of roles. And these are specific to specific namespaces. Some of these things are for doing some bootstrapping stuff for the way that kubeadmin works. If you didn't use a kubeadmin type of thing to actually start your cluster, you may not see that. But if we look at cluster roles, you'll see that we see a lot more. Oh, it says, oh, so if I try and say namespace, it's like, it's not a namespaced resource. You can't say that. And you can see that there's already a whole bunch of roles going on here. And one of the interesting things here is that if you look at how Kubernetes works with controllers, there's a whole bunch of things that do things like, well, here's the piece of code that manages the deployment object. Well, it runs under its own role. Or here's the thing that knows how to, let's see, run cron jobs or daemon sets, or even like, collecting pods after they've sort of been exited for a while and we want to clear them out of the system. So there's all of these sort of like standard stock roles that are actually part of the cluster. And one of these things is called cluster admin. Okay, and then there's also basic user. Let's look at basic user and see what basic user is, because I don't even know what that is. If we look at the documentation for RBAC, they actually, at the bottom here, they actually talk about some of the standard roles that we have here. So we have admin, edit, view. These are cluster roles, cluster admin. And then which one did I say? We have basic user. Basic user allows user read-only access to basic information about themselves. Oh, what does that actually let you do? So let's actually look at that, because I'm curious about that. If we look at that, subject access reviews. Okay, so I can actually create a subject. So this says, okay, within the authorization group, I can create a subject access review resource, and the verb is create. Okay, so the way that these roles work is it says which objects are we acting on and which verbs can we do on those objects. And the way that we identify objects are that we have this idea of an API group, which is a way of sort of segmenting the API surface area of Kubernetes. And then we have the resource type, and you can actually narrow this down to a specific resource if you want. Most of the time, folks are not that specific about these things. So let's go ahead and we'll look at the documentation again here. Okay, so here's a role that says I can do a whole bunch of stuff with pods, get, watch, and list pods. And no API group is sort of like this legacy core API groups, this stuff that we did in Kubernetes before we had API groups. And these things are cluster roles, okay? And so, but the one thing that I think is most interesting is that we're gonna actually go through and we have the admin role. Okay, so let's look at that. Cluster role admin. And this essentially says, and there's a whole bunch of stuff here, and this is managed for you by the system. And it says that with these resources, I can do these verbs. With these resources, I can do these verbs. And so this is a whole bunch of stuff that I can go ahead and do. And this is admin, and you could apply this across the cluster or within a specific namespace if you want. Okay, so you can have role bindings, roles and cluster roles that decide what you can do. Roles are namespace only, cluster roles cut across the entire cluster. Now, there's role bindings and cluster role bindings. So cluster role bindings essentially say, I'm going to let this user do this thing across anything in the cluster, right? So if I go through and say I want to give the pod reader role, this is a role binding. Let's look and see if there's an example of a cluster role binding. Okay, so anybody in the manager group, I want to actually go ahead and give them the secret reader role, right? So that says, and that cuts across all namespaces. And so this is actually a pretty powerful role binding. But let's go ahead and what we're going to see here is, I'm going to show you another cool thing. Kube create actually has this thing, and we're going to create a role binding. We're going to do help here. And so we're going to create a role binding says Joe. And we're going to do the cluster role equals admin. User equals, what was it? Users Joe is what I actually said. That was my name. I think that's what it was. You can do groups or service accounts. And we're going to do dry run. And this will actually, if you do dry run out YAML, this is essentially sort of does a template. So this is a getting started, so I don't have to copy and paste that YAML to go ahead and get started. And it's saying, okay, I'm creating a role binding. The name of the role binding is Joe. This is just so we can manage it later. And I'm going to actually create the ability. I'm going to use the cluster role, the admin cluster role. And I'm going to say that applies to user : Joe. So let's actually go ahead and actually run this for reals. So kube control get role binding. I actually see it there. Okay. Now let's actually switch up our kube config here. Now get nodes. I'm going to get an error. I'm not allowed to do that. But if I go ahead and get pods, it says no resources found. So I was actually able to do this. And let's go ahead and launch a pod. Kube control, or use my standard getting started. This was done for the Kubernetes up and running book, my standard workload here. So we're going to go ahead and just launch a pod here. And I can go ahead and do that. Get pods. Okay. So now what I'm going to create another tab here. Let's let me increase the font size here. And so, this was another window. I wanted to do another tab. Darn it. Okay. So here we have these two. Okay. So here to export kube config equals, so this is my admin one, and this is my Joe one, okay? So I should probably, let's see if I can do edit session. Let's set the background to colors. The background here, we're going to do sort of a deep green. Okay, hopefully this is still readable for folks. Okay. Okay, so the deep green background is Joe, and this one is my admin one. Okay, so kube control and get nodes. This one works because I'm admin. This one, it says no, user Joe is not allowed to actually look at nodes. So now what I can go ahead and do here is let's create another namespace. Kube control, let's see, create name. Do we kube control? Now there's a whole bunch of things that I can do. Can we do that? Yes, create namespace. So this is And then what are the flags for this? Name, and we're just going to call this foo, right? Namespace. Now I can do cube control get namespaces, and I have default foo and cube public and cube system. Okay, so now I can do cube control get foo get pods. Nothing there. So now I can actually go through, and here I see quard D is running, but if I actually go through, I want to actually switch to the foo namespace. Now I'm actually saying, okay, users Joe cannot list pods in namespace foo. So this is actually a lot right here. This is incredibly useful because what we can do is we can create namespaces, and then we can restrict what users can actually create which objects in which namespaces. And that's enough to actually get a lot done. And so a really cool pattern here, and I want to actually write an example for this using KSonnet, is let's say that you have a shared development cluster. You can have a list of users, and then you can take that list of users and create a namespace for each of those users. And give them, you know, certificates or authentication using something like say your Google Apps domain to actually authenticate them in. And so now you have it for each of your users. You can give them each their own development namespace, and then you can use RBAC to actually restrict who can actually do what with that namespace. And maybe what you want to do is you want to give everybody read access to every namespace, but then you want to only give them write access to their own private namespace. And so that ends up being a really useful way to do this stuff. And so let's go through, and we're going to go back here, and we're going to create a role, cluster role. Okay, so we're going to actually go through, and we're going to create a cluster role now instead of a role binding, cluster role binding instead of just a regular role binding. And it says Joe read only. Okay, and let's do help and. The cluster role that we're going to give it is view. And the user equals users Joe. Now, if I go back here and I try and get pods, it says no resources found. But that's great. Now I can actually read that. But if I actually try and go through here and do the quard D into this namespace, we're going to do a run -n foo. It's going to actually tell me I can't do it. So I can read pods in there, but I can't write pods. So let's actually do this from our admin mechanism. Okay, so now we have quard in the foo namespace. Now if I actually get pods there, we'll actually see that it's actually running inside of foo. Go ahead and do that. I can also do all namespaces, and you can see that we have a quard running in default and a quard running in foo. So this is the basics of RBAC and how it works. Let's see. Here's the guide again. You know, you can go and you can look at this stuff, and this gives you all the details of how stuff works. You have to really understand the API a little bit to understand which objects and which actions you need to do if you want to write really fine-grained policies. But if all you do is actually give certain sets of users read, edit, you know, admin access on different namespaces on a namespace by namespace basis, that actually gets you a long way, and that really helps you get to the point where you can start segmenting up a cluster across multiple users. Let's see. So here's some role binding examples. Okay, so the next thing I want to talk about is we have 5 minutes left. I do want to actually show something here. If we go to docs.heptio.com, we actually wrote a guide on some sort of, this is like more of an RBAC cheat sheet. Because what we find is that you'll start with a Helm chart, and that Helm chart won't work because of RBAC, and you're wondering, why the heck won't this thing work? The first thing you can do is there's within, and so the problem here is that a lot of times you have code that's running on Kubernetes that talks back to the Kubernetes API server to actually do its job. This is really interesting because these applications fundamentally integrate with Kubernetes. Before RBAC was turned on, the default access, okay. And then, sorry, back up a little bit. The way that you connect to the cluster is via this thing called a service account. So we can do, get service account. And every namespace actually comes with a service account. And so here we can see, here's the default one for the default namespace. Here's the one for the foo namespace. So if I do OYAML, what you can see here is that this is a service account. It's named default in the foo namespace. I can actually get it across all namespaces. And I probably have to remove the dash n there. So what we see here is that for most of these things, we just have the default service account. But if you want to have an application running, you can give it its own private service account, which is essentially a robot identity that program can use to actually talk to the rest of the cluster. And so this is a user that's on a peer to sort of like that Joe user that we created, but it's automatically managed by the system and made available to workloads as they're running. So that's great. But what would happen is when you turn on RBAC, that default service account, because most people before RBAC started becoming popular and started becoming best practice, most people would run with essentially zero authorization, right? So if you could authenticate, you essentially had root on the cluster. As you turn on RBAC and you start rolling that back, all of a sudden that default service account went from having root on the cluster to essentially having zero privileges on the cluster. And during that transition, it broke a lot of stuff because everybody assumed, hey, I can use the default. So if you hit a problem and you want to do this, the best thing to do is actually go in and change that program so that it's using a domain-specific, a sort of, a service account for that app, figure out what resources does it really need access to, and then craft an RBAC policy for that, right? And the RBAC policy will be probably a role and a role binding if it's actually dealing with stuff within its own namespace. If it has to deal with stuff across namespaces, then you'd create a cluster role and a cluster role binding and then that role binding would bind to that service account that you're creating. But a lot of times nobody has time for that. So what's so that's what I'm saying is the sort of most secure here. What can you do that's actually will get you moving without turning off security on your cluster altogether? So the easiest thing you can do here is that you can create a role binding that essentially gives the default. So here we have my namespace as your namespace, and my role binding, you can just give that a name. But if you create a role binding here that gives the default service account admin in the namespace, that essentially says, you know what, anything in this particular namespace can do anything in this namespace. That's not great. It's maybe not as locked down as you want it to be, but you're not giving it root across the whole cluster. You're only giving it essentially, root inside of that namespace. If it's something that fundamentally has to operate across namespaces, then what you want to do is you want to say, well, and it's usually in that case, it's running inside a kube system. You can give the kube system default service account access to everything in the cluster. Essentially, the cluster admin says you can do anything in the cluster instead of just anything in a particular namespace. That again, it's not great because you're expanding scope here. This pretty much says anything running in kube system that has that default service account can do anything across the cluster. It has root on the cluster, but you haven't turned off RBAC for individual users running in individual namespaces. So you're still getting some benefit. The last ditch effort here would be to essentially turn off RBAC altogether on your cluster. And so we'd really advise people not to do that. That's not something that you're going to want to go ahead and do. So I think we're out of time. Hopefully that was useful. We spent a little bit of time getting the certificate up and running, and I really want to thank, oh gosh, I'm so bad with names. Jacob, right, for actually sharing his write-up here. I will dig that up again. It was here on LinkedIn that he posted that. And I'll put this in the show notes so that y'all can find that, along with some of the help pages that I've been hitting here. I think interesting things that I'd love to talk about in the future, and I think do a little bit more prep on this stuff, is how do you actually hook this up to some sort of external identity system, right? So how can we use something like GitHub as our provider so that we can go ahead and log in with our GitHub credentials instead of actually having to manage these certificates? I think that that's really interesting. As you're developing RBAC policies, there's a question of if things start failing, how do I audit what's failing so that I can actually make sure that I'm catching this stuff? That's something that we're really interested in. There's some configuration that you can do of your API server where essentially it'll start, if you turn on the right debug levels, it'll start telling you when things start failing RBAC checks. And so you can use that to actually try out a program, see what happens, understand where it's failing, and then adjust your policies. And you can either do that in a mode where you're running multiple authorizers and you're doing RBAC first, but if RBAC fails, then you're letting things through. So you're permissive but auditing what's happening, or you can sort of run stuff and see where it fails and keep adjusting your policy. So that's a couple of sort of RBAC things that I think maybe we can cover in a future show. Let's see. So I think that's all the time we have. Today. So Daniel is saying you can do the audit logs to find out what requests are being done. Yeah, the audit stuff is actually still pretty new. It's not something that I've actually dug into yet either. So it's definitely something on my list to explore. Please let me know what else you'd like to talk about. I don't actually have a concrete topic in mind for next week. And so there's a lot of stuff that we can continue to talk about. We can look at storage. We can look at maybe admission controllers, which is another pluggable thing, and initializers and where that stuff is and where it's going with 1.7. Right now, this was a 1.6 cluster. Pretty soon, we're going to have a 1.7 cluster for our quick start, and we can go ahead and do that. Another topic that I was looking at is my friend Chris introduced this new project called Kubicorn, which is a sort of lightweight, sort of bring me up a new cluster. It builds on top of kubadmin, and so it would sort of be a replacement for the Heptio quick start. That might be something that we want to take a look at also. So go ahead and either the chat here or hit me up on Twitter and let's give some ideas and we'll figure out what we're going to go ahead and do next week. But that is all for now. Thank you very much for watching. I will post the recording pretty soon and tune in next week. All right, see y'all later.